All right, so here's what we have to prove. So we have to prove that actually, let me clean that up. So we have to prove that the log, so here it's missing the log. So we have to have log here. So log of a minus b over 3 is equal to 1/2 of log a plus log b. Plus log b. All right. So on another sheet on this page, I have properties that we are going to need to solve this question. So you have the product rule, the different log properties. You have the product, quotient, power, and those three are going to come in handy. And we're also going to need to use one of these. So let's get into it. So we want to start with one side of that we have to prove. So are we going to start with this side, or are we the left side? Or are we going to start with the right-hand side? And it's really up to you and whatever you see that is easier to work your way through. But let's see with the left. Let's start with the right-hand side. And the reason I say that is we can right away clean up the right-hand side using the product rule, sorry. And the product rule says that the log of a product is equal to the sum of the individual logs. So we're going to use it to rewrite the right-hand side. That means that we can rewrite the right-hand side as 1/2 of, instead of log a plus log b, we're going to have it as log AB. It's going to be, yep, log AB. Log AB. There we go. All right. And then let's go. Keep in mind the left-hand side, we need to end up with a minus b over 3, log of a minus b over 3. So we have an a minus b at the top of the left-hand side. And the reason I brought up the perfect squares is because the only way we cannot square root both sides here. We cannot square root that and end up with a minus b. That's not going to work. So we need to find a way, we need to rearrange that if statement so that we end up with something that allows us to have a minus b squared. That way we can now square root a minus b squared and be left with a minus b. So the way to do that, so again, keep in mind, a minus b squared is a minus a squared minus 2ab plus b squared. So we need to incorporate a minus 2ab to that if statement. So so this is the if statement. So if statement. So a squared. So I'm going to add 2. I'm going to subtract 2ab to both sides. So minus 2ab. And then minus 2ab. All right, so I'm not changing, because I subtract 2ab on both sides, I didn't change the actual expression. So from there, now I can rewrite that left-hand side as a minus b squared. And 11 minus 2, that's 9, so we have 9ab. Where am I going with that? We're almost there. So, but what we are going to do first, actually we can do that right now if we want. We can rewrite, because we have the AB here. So if we solve for AB, that means AB is equal to a minus b squared over 9. And we're going to plug that in to here. So when we plug AB, we get 1/2 log of, and then set up bracket. At the top, we're going to have a minus b squared and at the bottom, we're going to have 9. And now the cool part now begins. We're going to have to use a couple more product log properties, specifically the power rule and the quotient rule. So let's see. If you notice, the 1/2 is, this is like an exponent. So we can use a power, we can use product then power, or we can use power then up to, but let's use power rule first. So the exponent, whenever you have an exponent times a log, you can just bring the exponent over. And that's what we're going to do. So we're going to bring the 1/2 over. So it's going to be the log of this whole thing raised to the power of 1/2. Raised to the power of 1/2 over 9. Okay, 1 second. And then from there, we can then use the quotient rule. Because what do we have? We have the log of a quotient. And what does it say about a quotient? The log of a quotient is the difference between the log of the numerator minus the log of the denominator. So from there, we can do log of the numerator, but keep in mind, let's keep in mind, because you have a 1/2 here, the exponent is distributed to the top and to the bottom. So it's going to be log of a minus b squared to the power of 1/2. So times 1/2 really. Minus log of 9 to the power of 1/2. And then log of a minus b squared to the power of 1/2 is really, you multiply the exponents. 2 times 1/2 is just 1. So you're going to have a minus b, log a minus b. And then minus 9 to the 1/2. 9 to the 1/2 is just square root of 9, which is 3. So log 3. And we can use log properties for the final time, for the final occasion. And this is the log of the difference between two logs. And the difference between two logs, if you remember, this is going to be the log of a quotient, right? Right here. So we're going to have the log of the difference between two logs is the log of a quotient. So this is really log of a minus b over 3. And that is the left-hand side that we were trying to prove was equal to the right-hand side. So again, if you notice something, we worked with the left-hand side and the right-hand side separately. We didn't assume they were equal. We worked with them separately, and then we incorporated the if condition, the if statement, plug it into the right-hand side, and then it ended up, the left-hand side ended up being equal to the right-hand side. So when you're trying to prove that two sides are equal, never assume that they're actually equal. You could want to work with the two sides separately and then reach the conclusion that, oh, they're actually equal to each other. Thank you.